Good morning, everybody. My name is Peter Husey, and on behalf of AFA, the Mitchell Institute, and the Reserve Officers Association, and the National Defense Industrial Association, I want to welcome you to this, our ninth in our series of Space Power for the Warfighter Breakfast Series that Capt Ryan and I are hosting. I want to thank our friends from the Marshall Institute that have given us their resources in taping this, and so that it will be posted on their website. We will also have a transcript of this event within about 1 day or so, and we'll post that as soon as the speakers edit and look through it. Any of you who are here for an energy seminar, which I'm also doing this morning, that's upstairs. It's a long time in coming. We're beginning an energy security seminar series on national security implications of energy, and that's upstairs, and we'll be doing that once a month as well. I want to also remind you that December 5th is the final event for the year, and that is with General Hyten, the Air Force Space Commander, and that'll be, as I said, Friday, December 5th, and we'll be sending out invitations probably later today or Monday for that as well. I want to thank General Teague, who is here today as one of our guests, for his great help in putting this together, as well, of course, Capt Ryan. Also want to thank our embassy colleagues for being here, and our military as well for their attendance. We are also planning the 2015 series. Capt and I have sent out a PowerPoint around to various people, and we would like your input, as well as those of you who would like to sponsor who are not sponsors, please do. And I also wanted to thank our guests for the entire year for making this a successful series. We have two speakers this morning. Our first speaker is Charlie Woodrum, who's the Program Coordination Officer at NOAA's National Weather Service. He is currently the National Weather Service Program Coordinating Officer at NOAA headquarters. It's a 2-year rotational assignment. In his first year, he worked on the staff of the National Weather Service Director, and in that role, he took shifts at the National Operations Center as a meteorologist and maintained his proficiency at the Weather Forecast Office in Sterling. Our second speaker is Colonel Heath Collins, who's the Deputy Director of Remote Sensing Systems Directorate, Space and Missile Systems Center, Los Angeles Air Force Base in California. He assists the director in the development, deployment, and sustainment of the nation's space-based infrared detection, targeting and tracking systems, as well as sustaining and fielding affordable space and terrestrial weather systems. Prior to this assignment, the colonel served in the Office of the Undersecretary of Defense for Intelligence. He's worked on a number of space programs, including MILSTAR and Wideband Global Satellite Communications Program. With that, I would like to introduce our first speaker. Would you give a warm welcome to Mr. Charlie Woodrum?
Good morning, everyone. I'm Charlie. It's nice to be with you all here today. Thank you for the kind introduction. I'm a National Weather Service forecaster, meteorologist. I came here to DC from the Weather Forecast Office out in Pittsburgh, Pennsylvania. I got the honor to issue watches, warnings, and advisories for the National Weather Service, and have worked for the Weather Service now for 7 years. So I've just now had this amazing opportunity to be here with all you guys in headquarters, and worked with the National Weather Service Director for a year on his staff, and now I work with Dr. Capt Sullivan at NOAA headquarters on her staff for everything that's related to weather and any weather service related matters. So glad to be here with you guys today. So just to give you an outline of what I'll be talking about to you today, I'm going to give you a background of what the National Weather Service does and what the role of the meteorologist is with the National Weather Service to lay that foundation. I'm going to go a little bit deeper into observations and satellites and how forecasters at the National Weather Service and meteorologists utilize that information. Talk a little bit about space weather towards the end, and talk about a couple examples of partnerships that we have with the military out there. So just to give you a quick background of where I started, I grew up in West Virginia and went down to Florida State University, came in to the National Weather Service, the forecast office in Tallahassee. NOAA used to have this really awesome program where you could be a student intern for a year and then you get a non-competitive promotion after you finish, which was really awesome for me. Then I went up into the cornfields of Southwest Ohio and started my career at the Weather Forecast Office in Wilmington, Ohio. Became a forecaster in Pittsburgh, which was awesome because I got to issue warnings for my hometown of Morgantown, West Virginia. That's like every meteorologist's dream, is to get to go and issue warnings for your hometown and issue those forecasts and do the snowfall forecast. You know, those decisions that people are the information you're putting out, they're making those decisions to cancel school and things that you grew up as. Those meteorologists, what are they thinking? And then I found myself in that role. So that was an amazing opportunity. That normally doesn't happen because there's so few meteorologist jobs out there across the U.S. that it's rare that you actually get to go back to your hometown. We have 122 offices spread across the country, so the odds of getting to go back were rare. Then I had this awesome opportunity to come here to headquarters. So I've been here about a year and a half now. So the National Weather Service, we've got 122 weather forecast offices across the country, 13 river forecast centers. This is our watch warning advisory map that we have that you can access right off of weather.gov. That's how we display all our information, our easy go-to access area that you can get all the information you need from the weather forecast. Just to give you the broad vision of the National Weather Service, one thing that if you've heard talks from the National Weather Service recently or NOAA, one thing you're going to hear a lot about is our initiative to build a weather-ready nation. It's not just about reaching out, the Weather Service reaching out directly and teaching folks and educating our partners. Now it's about our partners making those connections with other people and pushing the initiatives from NOAA and the National Weather Service out to the community. Just as meteorologists, we can't alone communicate to all of the public and make all those connections. We have to rely on our partners too, from the private sector, from the media, from the military, congressional staff. We need our folks that we connect with then to reach out and push our initiatives, so then we can have a weather-ready nation. You talk to so many people today that don't really even know what the National Weather Service is about, what we do. They think it's weather.com or AccuWeather or something else. They don't really know. But what's important is we're the ones that are issuing the warnings, and we want people to understand that. We want people to be resilient. We want communities to have preparedness, and we are relying on all of our partners to take those initiatives to help us build a weather-ready nation. So that's our true vision, is to have a weather-ready nation, and all you guys here can help us do that. And so the mission that we have is ultimately saving lives and protecting property. But we're providing weather, climate, and water data, forecasts, and warnings with protections of life and property and the enhancement of the national economy. So this map here shows all the national centers that we have across the country. All the red dots that you see here are the weather forecast offices that are 122 of them spread all across the country. As mentioned prior, there is one right here in Sterling, out there by Dulles Airport, one of 122. We also have 13 river forecast centers that do all of our river hydro forecasts, Potomac River locally, and many other rivers across the country. On top of that, we also have a lot of national centers all across the country. Some of them, the ones, many of which are here in DC, include ones that are out at College Park, at NOAA's Weather and Climate Prediction Center, which is out there in College Park. We've got the Ocean Prediction Center, Environmental Modeling Center, Weather Prediction Center, Climate Prediction Center, and NCEP Central Operations, all located right here in DC. And of course, our National Weather Service headquarters are located here too. Beyond that, there's actually a couple other national centers across the country. We have the Aviation Weather Center, which is located out in Kansas City, also where the National Weather Service Training Center is. Our Storm Prediction Center, located none other than in the heart of Tornado Valley in Norman, Oklahoma, and our Space Weather Prediction Center that's out in Boulder, Colorado. On top of that, we also have a pair of tsunami warning centers located in Hawaii and Alaska, and we also have a brand new center that I'm going to talk a little bit more about our partnerships later, and that's the National Water Center that just opened up in Tuscaloosa, Alabama. We're really excited about that. So to give you a brief overview of what we're doing out in the weather forecast offices, that's our opportunity to really connect with our people all across the field, make those connections with our partners, make those connections with the local U.S. Army Corps of Engineers, make those connections with local emergency management, make those connections with the public, with all of our partners, all the people that really need that localized information, and providing them that localized, detailed level of information is what really people can use to help make their decisions. And we're doing something, it's something we've been doing for a while, but it's something we've been putting a lot more of a focus on. It's called impact-based decision support services. So it's about understanding what our partners in the emergency management or the education or the university or aviation, understanding what their needs are and then meeting those needs by providing specialized, specific information so so we understand what their needs are to make those decisions. And so really understanding the user is what's really important. Meeting with emergency managers and saying, what is it that really pushes your decisions? What are those thresholds? Not just here's a warning, here's what you need to go take action. It's about understanding what they're doing with that information and how they're using it. So the weather forecast offices are open 24 hours a day, 7 days a week, all across the nation throughout the year. They also push another really important part of what the National Weather Service does, and that's our Skywarn Spotter program. They educate all of all the public members on how to identify weather, and ultimately that gets us our information so we can put out accurate warnings and help save lives. So river forecast centers, I worked at a co-located office in Wilmington, Ohio, one of 13, and many of them are co-located with our weather forecast offices. Lower left here is actually a map. Probably a lot of you can't see it, but they're spread out all across the country. Our River Forecast Center here is based out of State College. It's the Middle Atlantic River Forecast Center, MARFC. So they're the ones that are providing, actually looking at hydro models and river forecast models and providing that information to the weather forecast offices so that we can issue river flood warnings and get that information out to our users of the rivers and our communities along the rivers and communicate the impacts of rising rivers. So our National Weather Service national centers that I covered, I've already hit on all those. I'm going to talk a little bit more about the Space Weather Prediction Center shortly. So the types of tools that we're using, radar, satellites, computers, observing systems. One thing that we're going to talk more about, and here's what the type of things that we do at the forecast office, but one thing I do want to talk more about here as we move on is satellites, specifically observations from satellites, because that's so important to how we do our job as meteorologists. So one big thing that really pushing this initiative with building a weather-ready nation has been an increase in extreme events. The average year in trends in the US. We've had 650 deaths on average with $15 billion in losses. 26,000 severe thunderstorms on average a year. 6 Atlantic Basin hurricanes, 1,300 tornadoes, and 5,000 flood events. And so you can see here, here's a map of different events that are occurring, and you can actually see the increase of loss events that are occurring. And all the green events that are here are actually the meteorological events, the ones that are specifically related to weather. But another one I want to highlight is that there's climatological events, which have been a really big thing here lately with the drought out west in California and all the fires that we have now annually. It's only getting more and more extreme with the impacts from both drought and fire every year. So that's become a really big impact to us. So we've got an increasing population, more extreme events, ultimately increased vulnerability. So it's something we need to be proactive with and engaging. So some people might think, oh, well, we've had the National Weather Service for a really long time, and we get great weather, we get information from the Weather Service, and we're getting forecasts, and models they're getting better. There's still a lot of room for improvement, but regardless of how good the forecasts have been, there's still been major impacts that have occurred, and there's been deaths, and it's ultimately what it comes down to is community resilience and preparedness. Regardless of how good that forecast is, there still are going to be impacts that need to be understood. So we obviously had Sandy here just over 2 years ago. We just passed the 2-year anniversary of Hurricane Sandy and its impacts on the Jersey coast. I was in Pittsburgh. We were actually issuing blizzard warnings for the Appalachians. We had 2 to 3 feet of snow, heavy wet snow up in Garrett County, Maryland, just out to our west here. So really big impacts from that one for different reasons than the flooding and winds that occurred along the coast. Obviously, everyone knows about Katrina. We also had the Eastern Colorado floods, which was a major impacting flooding event near Boulder, Colorado last year. And then last winter, the Atlanta Commuter-Geddon, it's called Commuter-Geddon 2 because we actually had Commuter-Geddon 1 here, where we had a really rough evening commute with just people stuck out for hours and hours and hours. And Atlanta just had the same thing. And there was a forecast out. It was for a couple inches of snow. They ended up getting a little bit more, and they just don't have the means to treat the roads down there. And so if you think we're weather ready now, the answer is clearly no, because we're still having these extreme events or these events that may come up quickly or could exceed what is thought to be what is expected in that event. And so we still need to be ready for those extremes. So to give you an overview of how things run through the Weather Service, where we start and how that information ultimately becomes a forecast and gets out to our decision makers. We start back with the original observations that we take. So we've got our ASOSs, which are out at the airports. Typically, they're out at airports. They take our ground observations. We've got buoys out over the water that can take wave height, temperature, all kinds of wind, all kinds of different observations there. Of course, we have the satellites providing us so much valuable information, and radar as well. Two of the things we rely on mostly, radar and satellites. And so then that information is taken into our central processing, our central computers, and then that is then processed into forecast models where we get our central guidance that goes to the forecast offices. We have our forecasters at the forecast offices monitoring this guidance, both guidance that comes from our national centers and from models, from the different models. The Global Forecast System, the GFS, is the model that we use. That's what is termed by some organizations or TV organizations as the American model. But the GFS is our model, and we also have some really new, exciting models. We just have a new high-res rapid refresh, the HER model, which provides us near-term, high-resolution radar forecasts and also other parameters too to help us make decisions in the next 24 to 36 hours, which can be really helpful in putting out those forecasts. So then once we have those decisions made and we've made our forecast, then we have to go through the decision support, dissemination process, and actually getting that information out effectively. And that's something that honestly can really be improved. It's something that we're putting information out on a system, weather radio, that's still county-based and still has a lot of room for improvement and can be modernized and needs to be modernized. And that's something that we have been able to make a nice leap recently by developing wireless emergency alerts, the alerts that come out to our phones, that we get those automatically. A lot of you probably got those. We got one about 20, 25 days ago when we had the tornado warning here for DC. We all got the alert on our phone. And those are saving lives already. There already have been several stories. I'm going to talk about one here shortly. So I'm going to move forward to that event now. November 17th, 2013, we had a somewhat rare tornado outbreak that occurred over the western portions of the Ohio Valley, and particularly impacted Illinois, was one of the central locations that got impacted. And we honestly, the forecasts that were going out well ahead of this were great. There were outlooks out 4 days. If you look at that lower left-hand graphic there, that's coming from the Storm Prediction Center, and that's their outlook, highlighting 4 days out that there's the potential for a tornado outbreak. As they're getting closer, they're really starting to hone in on that area between Illinois and Indiana and Ohio. And in 12 hours, they had a high risk for severe weather. It was really like the top tier level events. They only issue so many of those a year, maybe not even more than 10 a year. So we knew the potential was there for storms. The storms start developing. It's an early morning on a Sunday. So as you can imagine, a lot of people are out at church and normally not very aware and not going to be looking at weather information while they're at church. But thanks to wireless emergency alerts, folks that were at church services got that notification on their phone. And in the past, there actually have been deaths from tornado events in churches, folks that they just weren't aware because your thoughts are elsewhere. But thankfully to wireless emergency alerts in our pockets, that has really been a huge leap recently for us in dissemination. So it's been a really nice thing to have. And an EF4 tornado actually did end up ripping through the town of Washington, Illinois. There were 8 fatalities with that tornado. And what ended up happening, actually, there were several people at services that got the message and took cover. So it certainly helped save lives in this case. So I'm going to keep moving forward here and focus more on the observations here from the National Weather Service. So as I mentioned before, we've got our radars spread all across the country here. We have pretty good coverage across the East Coast. There are more gaps out west, primarily due to blockage from the terrain out west. And so then we have our ASOS, our Automated Surface Observing Sites, that take our ground observations, our wind, temperature, dew point, pressure, precipitation amounts. And then our cooperative observer sites, which are actually people out there all across the U.S. You can see all those dots spread out well across the U.S. there, where we're getting human observations. And then we also have our NOAA weather transmitters that are transmitting information out to weather radio. That's the lower right there, all across the U.S. So we're getting a lot of observations out there. On top of that, we also have our networks of buoys and also satellites that come from NESDIS. And our buoy networks, they're spread out all across the Pacific, Atlantic. This is really key information for a lot of different reasons. When we have a hurricane out in the Gulf or the Atlantic, getting those wave height forecasts and to really see how strong it is, pressure observations. But also another big one is for tsunamis. After earthquakes, we're able to monitor those through our buoys. So that's a really big thing, because we can help get the alerts out well in advance if we have those buoy observations. So we've been working really hard to ensure that our buoys are maintained. There are some cases where buoys get vandalized and they have to be fixed, and it's not easy because of the weather conditions out on the coast, especially up towards Alaska. There's only a certain window of the year that you can go replace your buoys. So that's something that we've been working really hard to. Then, of course, on the right here, we have satellites. We've got our geostationary and our polar orbiting satellites. And just like as basic of an overview of satellites as you can get, you've got your geostationary coming around the equator. That's basically making one loop around the Earth in a day. So you're staying focused on a specific area throughout the day, and then you have your polar orbiting that is moving over through the poles, making that polar orbit, taking several different shots around the globe as it comes around. So something we're really excited about as weather forecasters, our SWOMI MPP, which was launched in October 2011, offers us all kinds of great new products that we're able to use as forecasters. Something that I was starting to do, which was really neat, right before I left as a forecaster out of Pittsburgh, is we actually have now models that take satellite information and simulate the model forecast. So I was looking at simulated model satellite imagery to help make my forecast. So the more detailed satellite information we get, the better we can make our satellites. And then we have JPSS that's going to be coming with the scheduled, and that's a joint polar satellite system that's coming out here in 2017. And that's something we're really excited about as well, because it's our next generation of satellites. We're getting more detail, more information out across the oceans, sea surface temperatures out across the oceans, ocean color, land imaging, aerosols, clouds, imagery. There's so many different benefits here for Homeland Security, resources, warfighter support, and obviously the weather community, but public health and safety as well. So I wanted to just show an example of satellite and how a couple of different examples of satellite and how we're utilizing it at the National Weather Service. Here's Hurricane Sandy. You can see it there as it crossed from the Caribbean into the Atlantic, and then there's the red cone. There's the forecast track, and the satellite is as it came through there. And this really shows that we had a great forecast, even though our models were showing the GFS early on actually had the system at times, depending on the run of the GFS, had it going way out to Bermuda. We had ranges going from all the way from Bermuda to making landfall in the mid-Atlantic. So as a forecaster, this is like the ultimate challenge. You have an extreme, rare event with a huge window of different possible outcomes. And so this is where we do really make the difference and make the impact as meteorologists. You could have the best forecast or a very wide-ranging forecast, but it's the meteorologists that actually have to determine that uncertainty and make the decisions, which in this case, as you can see with the track forecast, they did a really good job with Sandy, despite some of the negative press that came out on negative about how the GFS performed with the event. The forecasts from the National Weather Service were excellent. So here's the geostationary GOES 14 shot of Sandy. This is a really nice, super rapid scan, high resolution shot of Sandy as it was starting to make that turn, that westward turn towards the Jersey coast. And so I'm just going to show a couple of different examples here of how we're using satellite. This is GOES 14, and this again gets into that high res. You're getting very frequent images here. In this case, we're getting images, looks like about every 3 to 5 minutes. And so what this is here is this is actually a tornadic supercell, and this is just a really awesome way to resolve and view a tornadic thunderstorm. The storm's actually right here, and I'm sorry for you guys way back in the back, but you can really start to see the clouds, the convection with the thunderstorm really come out, the overshooting tops of the thunderstorm, and then the upper level clouds, actually the cirrus pushing off, exhausting off of the storm. But what's really cool about this is it's so high resolution and the images are so frequent that you can actually get that feel for the rotation of the individual storm from satellite. So this just shows the leaps and bounds that we've come with satellite, being able to show things on that small of a scale. So a couple more things as I wrap up here. Another thing we're doing with satellite is monitoring fires. Out west, this is the King Fire in California. You can see the fire here. It's very, very evident right there. So as new fires develop, satellite's often one of our first ways as meteorologists in the field to be able to detect that. Another cool thing, and I apologize, the lighting just doesn't do this justice, but you can, one of those new things that we have been able to do is really just get the true colors from satellite. And this actually captured, this satellite image actually captured the change of the seasons. The left image is September 27th. You notice it's very green, and I know it's hard for you guys to see, but it's actually browner up here where things are starting to change. And then here, November 2nd, just a couple days ago, you can see it all browned up, and you can really see the features in the Appalachian Mountains where they have really gone past peak with the colors. So there's a lot of really cool things that we're doing now. So just want to touch briefly on space weather. We do have the Space Weather Prediction Center out in Boulder, Colorado. So space weather, obviously something that is a major concern here to us in the U.S. And meteorologists are actually getting tied into this as part of the National Weather Service, and we're the ones that can disseminate the information from the National Weather Service about space weather and get warnings out about space weather. So the big thing with space weather is we've got our Space Weather Prediction Center, we've got solar flares, coronal mass ejections that are coming out from the sun, and we have a system in place, a watch, warning, alert system, just kind of like we do for severe weather. Watches showing, just like if you had a severe thunderstorm watch, the conditions are favorable, warning meaning it's imminent. And so this is something, it's relatively a newer thing. It doesn't happen as frequent. It's not on people's radars often, but the impacts of a solar event could be massive if it's a major event. But one big impact can be from these events is impact to satellite operations, the range of loss of data to even the loss of a satellite due to one of these events. So being able to get that information when these coronal mass ejections occur, sometimes it may, from the time it develops, we may have 30 minutes to several hours, and then it can last for hours to days once it occurs. And you have those impacts of possibly widespread power outages, GPS impacts, but we can get a lead time on these. We're starting to get a lead time on these, and we're actually going to be launching a new satellite in January, the Discover satellite, that's going to help us get even more information about space weather and be able to provide we'll have even more information to put out watches and warnings and help people make decisions based off of that. So there are a lot of impacts to the satellite industry based off of space weather. So there's just so many different things that can occur. Satellite ultimately being rendered useless really is a huge impact. So we also have all kinds of different impacts. We have geomagnetic storm impacts that impact satellite operations as well. The GPS, the power grids, aircraft operations, another big one that gets impacted here. And also if there are folks out there manned space flight, there are impacts as well. So tying back to our original theme of building a weather-ready nation, it's not just about the traditional terrestrial weather that we think of. It goes far beyond that. It goes all the way from the sun to the sea. So we're talking impacts from space weather all the way down to the local change of winds or downsloping winds that really could be impacting you on a very local scale, a meso scale, all the way out to space observations that lead to our forecast. So it's a really overarching huge system. So there are a few partnership examples, and I'm not sure how I'm doing on time. I have a little over. Okay, so I'll just touch on these real quickly. We have a lot of great partnerships with the military out there. Sorry I can't go into these more, but a lot of you guys I'm sure are already familiar. We work with the Air Force with the Hurricane Hunters out there out of Biloxi, Mississippi. They provide us critical observations for the National Hurricane Center as we put out forecasts there. We also have the Office of Marine and Aviation Operations, OMAO from NOAA, where we work with the Coast Guard really closely. We have the National Ice Center. We work on products with them in coordination with the Navy and the Coast Guard. And this one brand new national center, I want to make sure everyone's aware of that it's already open, the center's open. It's the National Water Center in Tuscaloosa, Alabama. And it's something we're really excited about. We're going to be getting our initial operating capabilities going here in May of 2015. When we have the official ribbon cutting ceremony, we'll start off with about 30 to 40 employees there. The idea here is going to be that we have an interagency center. We're going to have the USGS, FEMA, and likely get the U.S. Army Corps of Engineers here involved with the National Water Center and have folks working in the building side by side, something that we haven't been able to have on the national level in the water community. And there's so much value to be having that partner from another agency working with you side by side as you're developing hydrological prediction products, developing models, making better models, and ultimately determining the best ways to communicate this information, because USGS, Corps, FEMA, Weather Service, we're all trying to put out information to help our users make decisions. And if we have all that coordinated, we're putting out a consistent, unified message. So we're saving lives through these partnerships, whether it be interagency or with the public or with our users. So it's something that's really important. So thank you all for your time, and I'll be available for questions after. Thank you.
As introduced this morning by Peter, Heath Collins, Deputy Director out at SMC, in the Remote Sensing Systems Directorate, and I'll touch on that in just a little bit. But wanted to build on some of the stuff that Charlie talked about, and in particular to talk about what SMC brings to this whole weather enterprise. I do not have any charts, because actually after seeing Charlie's charts, I think I would be completely embarrassed by the quality of my charts. I need to figure out how you get the spinning Earth onto each slide. But first, I want to first thank Peter, thank Capt, thank the Mitchell Institute, the Marshall Institute, ROA, NDIA to set this up. This is a great opportunity for the space community to come and talk and really pass on the importance of what we're doing to the DoD missions, but also to the civilian missions across the country, and it's a great honor. I'm in the last of the whole series, so I think you've gone through this year through all the other missionaries that we're doing. Expectation setting. If you thought they were saving the best for last, don't count on that. They are actually General Height next month. All right. So weather. As we talk about weather, there's as Charlie just touched on, there's so much complexity to the weather enterprise, and just seeing similarly from the civil side, there's also weather military weather applications as well, terrestrial weather, space-based weather, space weather looking down, space weather looking up, and all of those contribute every single day to every mission that the maybe minus cyber. Every mission that the military and the Department of Defense executes every day counts on weather. Weather is involved in every single thing they do, from launching satellites. Every single one of those space missionaries you learned about today counts on weather in some way, shape, or form through that mission. And so as we merged the SBIRS program with the weather program, I did not have a weather background. I had a SBIRS background, and so understanding the wealth of different phenomenologies and what they do, SBIRS was focused on infrared, but then all of a sudden this new weather mission area comes over as we merge the directorates, and I find out there's really not a phenomenology within remote sensing that doesn't apply to weather, and we use them all: RF, microwave, EO, electro-optical, infrared, radiation. All of it comes to play in providing the weather capabilities that our forces need. And so I wanted to touch real quick on a little bit of history on the space-based weather side, on the DoD side, and touch a little bit on where we are today and where we're going forward from SMC and Air Force Space Command. So weather was one of the initial mission areas when space first started in the Department of Defense, and so for well over 50 years, the department has been developing and launching space capabilities. Today, we rely on a large federation of space-based sensors, both military as well as civil and international, to deliver the capability that's needed across our mission sets. There's the polar, the little orbits that Charlie talked about. We count on a mix of polar orbiting. Those are much lower, sun synchronous. They cross the same spot on the Earth, same time every day. As well as the higher geostationary satellites that are basically constant stare and high revisit rate. And the combination of those two give us a ton of that capability that we require. And the U.S. Air Force, the DoD part of that is we provide the Defense Meteorological Satellite Program, DMSP. We've been doing that for decades now. And we're also then matched up with NOAA providing the POES, the Polar Orbiting Environmental Satellite. And then all the geo capabilities that we count on and rely on are provided by civil and international, both the GOES from NOAA as well as European and international partner capabilities. And so NOAA had been working POES, and DMSP had the Air Force had been working DMSP. And then back in the 90s, everybody's heard, a term I'm not supposed to use anymore. I got hissed at when I first talked to the weather folks. We brought in, I talked about NPOs, and I got hissed at when I brought it up. But that was an effort where, on paper, it looked great. The civil side's making polar satellites, the Air Force is making polar satellites. Let's bring those together and just make one polar satellite program to meet all of the diverse requirements that's needed. Pretty much how that went is for the history books, and there's many lessons learned on how that went. Eventually, the NPOS program had a lot of complications, many due to the complexity of that design of the one-size-fits-all, put everything on, and to meet the disparate requirements of both scientific and weather and DoD requirements. It was a very complex satellite with a ton of capability, but managing cost and delivering on a successful acquisition proved a little bit too much, and then the NPOS program was canceled. As that program was being canceled, the decision was made for the DoD to pick up its requirements and go back to procure a weather satellite. At that time, it was called the Defense Weather Satellite System, DWSS, and then NASA, the civil side, would go and build the Joint Polar Satellite System that Charlie talked about. And so as we were proceeding down that route, the DWSS program was kicking off earlier this decade, around 2000, 2011. And as we all know, the budget environment became much more constrained. It became much more of an issue. And due to affordability issues, the the DWS full set of requirements it was meant to be, it was going to be a multi-billion-dollar satellite program. And at the time, with the budget-constrained environments that and the decisions that the department had to make, it was chosen to terminate the DWSS program, and then we would still continue to fly out DMSP. And so that's where we are today. We just launched Flight 19 earlier this year and turned it over to Ops back in June. And so it's executing well, and we have a strong constellation of DMSPs, and that allowed us the department time to figure out what it was going to do next. Just as NPOS was terminated, DWSS was terminated. A new set of requirements were developed and validated by the JROC and included in the ICD, an initial capabilities document, which really listed 12 main high priority Cat A capability gaps that were required of the department. And then the department decided to kick off an analysis of alternatives. We called it the SBEM AOA, the Space-Based Environmental Monitoring AOA. And for the first time, it's probably one of the first AOAs that really took affordability, capability, and the broader landscape into mind as it was deciding where the department needed to go forward. And first thing it did was it took a look at those 12 capability gaps and really decided through modeling which of those gaps provided military utility and on what level. And that was pretty new, and through that, it actually determined one of those gaps, auroral characterization, actually didn't provide the military utility that was worth the cost, and so that one capability gap was decided did not have enough military value for the department to pursue a material solution. And then for the other 11 gaps, it took a look at the current civil and international capabilities that were fielded and were being fielded, and rack and stacked and determined based on the need dates of filling those gaps, what would require a material solution and which could count on civil and international. And at the end of it, of that AOA, the result was there were 3 gaps. We affectionately know them as 3, 8, and 11, that were identified as having a military utility and requiring a material solution that needed to be pursued by the department, by the Air Force. And those 3 gaps, Gap 3 is ocean surface vector winds. So the ability to not only measure from space wind speed, but also the direction that it's blowing. And so it has a big impact on our naval operations, on positioning of forces in the oceans, on air operations off carriers. There's considerable impact that would be required. And so that was one. Gap 8 is tropical cyclone intensity, also another very important one for our forces in the naval regions. And then the last one was a space weather requirement. It was low Earth orbit, energetic charged particles. And so that was a radiation characterization capability. And its main military utility was more in the space situational awareness realm. If you knew from a radiation perspective and could establish what the background radiation is on your satellite, you then would be able to tell if something happened to your satellite. You could tell potentially if somebody was interfering artificially with your satellite, or was it actual natural background. And so those are the 3 gaps that came out of the AOA as needing a material solution in the near term. And the Air Force has decided to stand up the Weather System Follow-On, the WSF program, which falls under the program office out in LA under us. And the focus of that program is to address those 3 gaps. And the Air Force, along with the Navy, the Army, and the other services, are also then looking at what we call non-material solution, non-major acquisition solutions, to ensure the other gaps are met through a combination of international and civil users. But as well, we also need to maintain, well-laid plans. Don't always happen, and so we're going to continually keep track of the global environment for environmental monitoring to make sure that while we may be relying today, and we believe we can rely on international and civil to provide the other gap capabilities that we require, if need be, we need to be prepared with enough lead time to fill those gaps if need be with a material solution on our own. So that is still in the cards. So that is the plan. WSF is we're just starting now the acquisition planning. We should have ACT strategy through our program executive officer, General Greaves, by the end of this year, and we're going to start communicating and integrating into the building to start that acquisition. We're shooting for a milestone A, which is our initial tech maturity and risk reduction phase milestone through Mr. Kendall. We're looking to get that sometime in FY15 in this coming year, and we're looking forward to starting that acquisition and delivering that microwave, ocean surface vector wind, tropical cyclone intensity capability as absolutely fast as we possibly can to the warfighter. So in closing, just again want to highlight how important the weather systems that we provide are to the joint warfighter and to the civil part of the government as well, and the partnership between the government, the DoD, and the NOAA and the civil side. It's a long-standing relationship. It's been bumpy along the way, but it's still a must-have relationship that we have, providing that joint capability to our warfighters. And so the Air Force has a long history of providing that weather capability and being part of that enterprise, and we look forward to continuing that into the near future. So with that said, I think I think I bought back a little bit of time, and I think we'll open it up for any questions. I'm not sure, Peter, how long we have for questions. Okay.
Okay. I have a question. One that's somewhat facetious and one that's serious. The facetious one is, are you guys working together to help support the New England Patriots with their weather predictions? And Coach Belichick apparently isn't thrilled. That's actually, I'm just kidding. You don't have to address that one. Unless you want to. The serious one.
As a Giants fan, I don't really care about it.
And the serious question is for the Air Force, can you help us understand a little bit the calculation that is now going on about whether to launch DMSP Flight 20 or not? I know that's being considered, and there's some issues there. Could you help us understand a little bit what that calculation looks like to you?
We can touch on a little bit. We are that decision is still yet to be made on the launch of Flight 20 this year. OSD and NOAA have conducted an analysis that was requested by OMB to look at the impacts of not launching F-20. That report is in coordination, and I believe it's at the DepSecDef level currently, and should be signed out shortly. And that will then go back over to the OMB and the Executive Office of the President to make that decision.
I actually can answer your first question. So I actually work on a national program called the National Lightning Safety Team, and we have a National Lightning Safety Toolkit, and I've been working weather safety with large venues across the country. And I met with the NFL at the end of September, and I can tell you that the NFL actually has a private sector company that provides them with weather information, and they really are looking for all the information they can get, whether it's from the weather service or the private sector, to help their stadiums make decisions. So it's definitely on the NFL's radar and a concern to them, and obviously Mr. Belichick's as well.
Thanks. You mentioned the potential to, as you relook at things from the AOA process for the weather constellation. One of the things I think the Air Force was relying on was the European constellation, both GEO and LEO. We just got back from some European trips and discussions. They're not likely to replace the geostationary satellite that's currently over the Indian Ocean, which is critical for military purposes, right? Mission planning and things. So I don't know if that you have to recalculate or how you reevaluate that, but that's something that we were at least told that was part of the basis of your analysis. So I don't know if you know anything about that, or if you relook at that issue.
You're absolutely right. There were ground rules and assumptions done as the AOA was conducted in what we knew at the time, and so the METSAT 7 change from the Europeans is absolutely got to fit into the calculus as we look to make the decision going forward. From losing a GEO and the impacts, what we could do in LEO versus a GEO satellite, and that trade, that is definitely in the calculus, as well as some of the other underlying assumptions of foreign capabilities. Those change over time, and so we continually to work, and we're trying to establish a good relationship with NOAA to stay on the pulse of what those international systems are doing. So as soon as we know about a change in plans, we can incorporate that into our risk management process and make decisions as quickly as we can. So thank you.
Hi, Colonel Collins. This is Amy Butler with Aviation Week. Just wanted to ask you about the WSFO. You said you wanted to get it on orbit as quickly as possible. When do you think is realistic to expect it to be on orbit? When does the warfighter need it? And how, if at all, does that affect your calculus on the 20th DMSP?
Okay. So right now our acquisition strategy that we're setting forward, the first objective system vehicle for WSF, we're looking in the 21 to 22 timeframe for the first launch of that satellite. Now the need is much driven by there's a technology demo satellite on orbit called WinSat that was produced. It was an NPOS sponsored demo that NRL built and launched back in 2003. And it is on orbit. Its end of life is expected to be met in the next couple of years, and so that's the critical gap, and that drove a lot of the AOA thinking as well. Why this material solution was prioritized so high, was there is an issue with WinSat ending early, and then when we can get WSF, and so we're also looking at a number of other alternative options to try to get some capability in the gap. I hate to use the term gap filler. I used to work WGS, and once you're called a gap filler, you can never get rid of that name. But we're looking at some improved algorithms on the ground that could potentially provide some partial capability. As well, there's some tech demos we're looking at as well. With JPL and/or NASA to try to deliver capability as soon as we can. Probably not full WSF capability, but at least partial to meet that need. And then I think you also then asked about how does that impact your decision on F-20. The particular capability we're looking at, the ocean surface vector wind is the main one that we're going to be losing with WinSat. The microwave payload on DMSP does not provide the vector wind part of that. It can do the speed, but it can't actually provide the direction. And so it would continue to provide that speed, but would not meet the requirement of WinSat. So it's somewhat relevant, but not quite related to the DMSP Flight 20 decision to the WinSat end. Does that help? You're welcome.
Colonel Mark Sellinger with Aerospace America magazine. How many satellites do you anticipate building under the WSF program, and do you expect to have all dedicated satellites, or might there be some hosted payloads involved?
So the requirements as they sit today, it is a one-ball constellation to meet a 22-hour visit rate, and so that is the constellation size as we go forward. And as we're developing the acquisition strategy, we're deciding how many we buy in this first buy. Do we buy the first two? Do we buy one and look to compete again on the second vehicle? We're still working and hammering out the ACT strategy for that. And then you had a second question, whether we're looking at hosted payload. We always look at hosted payloads. It's a unique environment where there are not a lot of hosted opportunities in LEO. And second, the microwave sensor that we utilize to do the vector winds and the TCI, the tropical cyclone intensity, is a fairly large payload with a good-sized dish of over 1.5 meters. And so it's not quite a small box that we can find room on a satellite in LEO. So while we will continue to look for those opportunities, the WSF acquisition is looking to buy buy a whole satellite.
Okay. For both of you, we've talked a lot about satellites and ground, but I didn't see a lot about airborne assets, knowing that UAVs are becoming more capable and more accepted in airspace, or even use over the ocean in things like the Hurricane Sentinel over the Atlantic Ocean. Is there any plans to consider that in alternatives for augmenting the National Weather Service capability, or looking at defense weather solutions in the future?
Sure, yeah. I can connect you with the right person to talk about UAVs and the future use for the Weather Service, so touch base with me after this.
in Marty, kind of a similar answer is I'm in the Space and Missile Systems Center, and so we're part of a lot broader weather enterprise within the Air Force, and so that would be we could get you in contact with the broader part of the weather enterprise beyond just the space-based side.
Thank you. Colonel, I want to thank you very much for your remarks.
Thank you.
Thank you, Charlie.